Okay. So, okay. Right. So for this one, guys, come give me 5 minutes. Okay. You're given the derivative equation, right? So what is this derivative equation? Well, f dash of x, okay, is equal to, if we simplify it, f dash of x, the derivative equation is x squared plus 2x minus 3. Okay? So, you're happy with that if I times it out? X squared plus 2x plus 1 minus 4 is x squared plus 2x minus 3, right? Okay. So, when do things change gradient? The original function, if this function derivative is a quadratic, okay, f must be what kind of graph? One more, right? A degree more, because when I differentiate, I've got to get to x squared. When I differentiate f, I've got to get to x squared, right? So the original function f of x must be a cubic function. Okay. Yes. And not only that, because this is positive, when I differentiate, the one before must be positive. So it'll be a cubic function which has this basic shape. Because it will start with positive x cubed, right? It will be something x, f of x will be equal to ax cubed, blah, blah, blah. But this must, because this is positive, this must also be positive, which means it starts with a positive gradient and ends with one. So that's the original function. Okay, we'll get to that just now. Okay, f of x has to do with, that's f, that's not this one over here. So this derivative function, x squared plus 2x minus 3. Okay, when do you get stationary points? Nice look that you've got going there. When do you get stationary points? When your f dash x is equal to?
Yes.
Okay. In other words, the x-intercepts of your derivative graphs are going to be your stationary points or turning points of your cubic function, right? Okay, so we've got f dash of x, so I'll solve this. You can use your calculator if you want. Just use equation mode, but it would factorize to less u x plus 3x minus 1. So you get x is equal to negative 3 or x is equal to 1. These are what? Your x-intercepts of your derivative function, right? Okay. What's the turning point of your derivative function from this pattern? F of x is x plus 1 squared minus 4. The turning point would be 1 to the left, which is negative 1 and negative 4, right? So they didn't say this to me, but if the question is saying when is it increasing? Okay. Because here, remember this, f of x, if you've got ax minus p plus Taylor, okay, do you get this? Why it's negative 1, 4. Okay. So what does f dash of x look like? Okay, it's a positive parabola, right? It has a turning point at negative 1, negative 4. So we weren't asked to draw this, but this is just a tool to help us. That's x. The y coordinates now are not y coordinates, they are derivatives of the original function. Right? So, x-intercepts are where? Negative 3 and 1, right? So this is the graph of f dash of x. This is y is equal to f dash of x, right? This is a derivative graph. Okay. So the y coordinates of this point, any point in this graph, what is the y coordinates? It's a gradient of the original function, right? So at this point over here, what is the coordinates of this point there? The coordinates of that point are, okay, negative 3, 0. What does that mean? That when x is negative 3, the gradient is 0. So this is a stationary point on the graph f, the original graph, right? What's the coordinates of this point? 1, 0. This is a stationary point also on f, right? Okay. Now, the question says, when is f of x increasing? What does that mean when the function is increasing? It means when has it got a positive gradient? Okay. So when does this parabola, when the y coordinates are positive here, the gradients of the original are positive. In other words, it's increasing, right? So this is the region we're looking for. Okay, that's where your y coordinates of your derivative graph are positive. In other words, the gradients of the original are positive in that region, right? Does that make sense? It's quite tricky. Okay, but the question says, you didn't have to show any of this working. Okay, you probably have to have done that. Okay. The question says, for which x values are these positive? So the function f will be increasing when the derivative function is above the x-axis So how am I going to describe this region? Well, here's the one set of answers in red. Increasing means not equal to 0, right? Just bigger than 0. So where is it increasing? It says which x value, so put your answer on the number line. So there's your first region. Then over here, it will have negative gradients, it will be decreasing. Okay. And then over there, it will be increasing again, right? So what's your final answer? When is f increasing? When x is less than -3 or x is bigger than 1. If you use interval notation, it would be x is an element of -infinity, -3 or 1 to infinity.
So,
Okay, yeah.
could you solve it as a quadratic inequality?
You could, but it's a lot more than that. I mean, did you get the same answer? Yeah, you can. So you could have said, you could have done this, you could have said when is x squared plus 2x minus 3 bigger than 0?
Yes.
And you could have then, to do that, you get the x-intercepts, right?
Yes.
So you almost do draw the graph to do it. Okay. You finished, guys?
Oh, and I still.
No. Right. Okay. Now, the next one. Okay. It says use the information you're given, okay, to draw a sketch of, not of f dash of x, but of f of x, right?
Yes.
So the first thing I would do is I'd say, remember, okay, that this basic shape of this graph, you should end up with a picture that looks like that roughly. Start with a positive gradient and it ends with a positive gradient. Right. Now, what do they tell us? First of all, we know where are the stationary points? At x is equal to what? -3 and 1. So I'm not going to draw them in yet, right? So at -3 and at 1, along these lines, I'm not drawing in asymptotes, I'm drawing in lines where the stationary points will be. Okay, now let's think about it. Before -3, what are the gradients? To the left of -3, here's -3. To the left of -3, what are my gradients? They're positive, right? So the original function is, these are my gradients that I'm sketching here. So the function must be going uphill, right?
Yes.
After -3, what are the gradients? Negative. So what's going to be happening at -3? It's going to be a local maximum. Or you could just remember the shape. The first one must be a local maximum, right? Okay. Then the other critical gradient changes at 1, right? To the left of 1, what's my y coordinates there? Negative, which means the function is? Okay, to the left of 1, the function is decreasing. After 1, what happens to the gradients? They become? So at 1, you're going to have a local minimum, right? Okay. So the function's going to go up to local maximum. Okay, but now it says, okay, where is the point of inflection always? In between your stationary points. Okay, this is where the gradient of the gradient is 0, right? This is where your second derivative is equal to 0. The turning point of the first derivative is where your second derivative is 0, right? So this is going to be your point of inflection. The turning point of this graph is going to be your point of inflection of the original graph f. Because the derivative of the derivative is equal to 0. This is where the gradient of the derivative is 0. Are you with me? So your point of inflection is going to happen where? At x is equal to -1, right? So along this line over here is going to be my point of inflection. Okay, so my point of inflection will be along that line over there. It's halfway between, mine's not to scale, between -3 and 1. Okay, and then they tell us that this original graph f only has what? What is f of x is equal to 0? What does that give us? What's that talking about? Where is f of x 0? That's where your y coordinates are 0. So what is that? Your x-intercepts. So they're saying to you that you've got one negative x-intercept. Okay. So now we can draw a rough sketch. Everyone's graphs wouldn't look the same. Okay. First of all, I'm going to do it in green. I've got a local maximum at -3. Right? I don't know what that y coordinate is. Call it y1. I'm going to have one negative x-intercept. So it goes up to that point, right? Here's my negative root. So I've done that. So there can be no more x-intercepts now. Because there's my one negative real root. Okay? What happens here? It turns, right? And it turns, it's going to go somewhere down there, right? Okay. And you're going to get a rough point of inflection. Oh, mine's not there. Wait, let's do that. You're going to get a point of inflection. The graph's going to change from concave down to concave up around about there. It's not very accurate, mine. Doesn't matter, it wouldn't penalize you. Okay? And you're going to have a local minimum at 1, remember? And then what's going to happen? It's going to carry on increasing. So our graph is going to, how we mark it, well, that'll be negative 1, y2, 1, y3. Recognizing that, the shape, the one negative root. Okay, guys, so be careful. There are like those questions where they give you the derivative function. Okay. Graphs are going to help you to answer questions properly. I do thank you. Have a very nice, rhyme with no reason day.
Yeah.
Video is not there.
Just leave that for.
What do you mean?
Attention.